In this video, we're going to learn to translate the construction process of a symbolic equation. So in the last section, we constructed equations given an initial value for a variable. In this section, we will be given an equation and we will determine the process of constructing the equation. We will use the terminology outlined in the table below. So this table is in your media lesson packet, and if we're starting with x or some previous result, we'll see how this applies later, and we want to add 3, so go to x, from x to x plus 3, we will describe this process as x is increased by 3, and we will call the result of the process the sum. Okay? So notice we have all of the different operations. For subtraction, we will say decreased by, we call the result the difference. For multiplication, we'll say is multiplied by, we call the result the product. For division, we say is divided by, and we call the result the quotient. And then we have one more that you may not be as familiar with, so let's look at an example. Remember from fractions, if you had 2/3, we called the reciprocal when you rewrite the fraction 2/3, reversing the numerator and the denominator. Okay, so this is a process we may need to do in our algebraic equations. So the idea is, if you have x over 1, okay, reciprocating it gives you 1 over x. Okay, so remember there's always a 1 under there if we need it, so we can rewrite this as 1 over x. So when we perform this process, we will say that x is reciprocated, and we will call the result the reciprocal. Okay. So now let's get started. Determine how the equations were constructed using the variable as your starting point. Write each operation and result using the language outlined above, and write each step on a new line and number each step. Okay. So here we have the equation. You could say 3x plus 1 equals 5. So we're going to think about how this equation is constructed, starting with the x value. So I'm going to put step 1 here. Now you could imagine if you put a value in for x, what is the first operation you would do? Well, x is multiplied by 3. So that's how we're going to start. X is multiplied by 3. Now our next step, we're not starting with x, we're starting with x being multiplied by 3. Okay, so x multiplied by 3 is our 3x. Now we want to take that and add 1. So we'll say the product is increased by 1. Okay, and we said product because the previous operation was multiplication. So now we have 3x plus 1. Okay. And the third step, that's everything on the left side. And the third step is to say, and the result is 5. So if x is multiplied by 3, the product is increased by 1, the result is 5. Okay. And the is the result, kind of like is, will give us this equation right here. Okay. So let's just highlight this. So we started with multiplying x by 3, taking the product, increasing by 1, okay, and then we said the result is 5. And that gives us this equation. So sometimes we can call this constructing the equation. Sometimes we'll call it the story of x because we're telling the story of how you'd build this equation while focusing on the variable x. Let's look at the next one. So here's x. Now we're going to start by, we have x minus 2, so x is decreased by 2. And since we did subtraction, we call the result of that the difference. So now the difference is well, we've done decrease by 2. The next thing we would do is multiply by 4. So the difference is multiplied by 4 Now our third step, so now we've done all of this, is we would add 12. So since the difference was multiplied by 4, this result is the product. So we say the product is increased by 12. And that gives us the entire left-hand side of the equation. And we end with, just like we did here, the result is 8. So this describes the story of how we would construct this equation based on x. Okay. So the first part, x is decreased by 2. Okay. So these words are really our answer, but I'm also putting the symbolic steps because it's useful to see. X is decreased by 2. You have the difference and you multiply it by 4. Notice we put the x minus 2 in parentheses because we're multiplying the difference by 4. The product, well, this is the product. It's increased by 12. And the result is 8. And that's our equation. Let's look at the next one. Okay, we have a lot of things going on here. Let's take a second and just look at how many operations. So we have subtraction, then division, then multiplication, then addition. So there's 1, 2, 3, 4 operations till we get to our result. So let's start with x is decreased by 5. Now we take this result, this difference, and it's divided by 2. So we'll say the difference is divided by 2. Now we call the result of dividing a quotient. So now we're going to take this quotient and multiply by 4. The quotient is multiplied by 4. So now we have this product, and we're going to add 6. So the product is increased by 6. And that's our entire left-hand side, so we'll say the result is 18. The result is 18. Okay, so we've written this in words. Let's just write the symbolic pieces as we go so we can acclimate to this process. So x is decreased by 5. The difference is divided by 2. The quotient, so this previous answer, is multiplied by 4. Notice we have to put this in parentheses to multiply the whole quotient. The product, well, this is the product, is increased by 6. So we add 6, and the result is 18. So now we can set this expression equal to 18. Okay, let's look at the next one. Just going to check to see. So we have a variable a here, so we're going to start with a. It's divided by 2. Then that result, we subtract 5. Take that result, multiply by -3, and the final result is equal to 7. So let's start at the beginning. A is divided by 2. Then we would subtract 5. So since the last process was division, we'll write the quotient is decreased by 5. Now our next step, so that's everything in the parentheses, we're going to multiply by -3. So since we just decreased, this is a difference. So the difference is multiplied by -3. And then that's the entire left-hand side of the equation, so the result is 7. We have 2 more to practice, and I suggest you try doing these steps on your own for practice. I just wanted to show you the first few. Okay, so these ones have fractions, but do not fret. Here we're going to start with A, and we're going to take it step by step. So one thing we could do is think of this as 3/2 times A. We said that we can write this as a coefficient, but we're going to look at the structure exactly how it is and think of how this was built. Okay, so if we put in a number for A, say 5, the first thing we would do is multiply that number by 3. Okay, so we'll start with A is multiplied by 3. Okay, then we'd have 3A. Then we're going to divide by 2. So the last step was multiplied, so we'll say the product is divided by 2. So that gives us 3A over 2. Now we're going to add 7/3, and the last part was division, so we have a quotient. The quotient is increased by 7/3, and then we have the result is 2/5. So not too bad. Okay. And now our final problem, this is where we'll need that reciprocal idea. We're starting with x. X is down here. Okay. So it's down in the denominator, but we're just going to think again of how, if we put in a value, what we would do to that number in a step-by-step process. So we're going to start by building the denominator. So the entire denominator is 3x plus 1. So the first thing we do is x is multiplied by 3. Then we have the product is increased by 1. Now, here's the steps. So what we've made so far, here x is multiplied by 3, the product is increased by 1. Now we want 3x plus 1 to be in the denominator. So now that we have the whole denominator, we want to get 1 over 3x plus 1. So we're going to reciprocate this. So we could think of 3x plus 1. Just make some room. As 3x plus 1 over 1, and we want to reciprocate or put the denominator in the numerator, numerator in the denominator. So that's the next step. So the sum is reciprocated. Okay, so at this step we now have 1 over 3x plus 1. Okay, so this is a quotient. And here we're going to think of this as 7 times the reciprocal of 1 over 3x plus 1. So we need to get a 7 there. That's our next step. And I just wanted to show you why we can think of that as multiplying the reciprocal by 7. So the reciprocal is multiplied by 7, and finally the result is negative 2/3. And we're done.